All right, exam season is closing in, right? Feeling that pressure? Well, you've come to the right place. Today, we're going to tackle a topic that shows up all the time, embedded systems. And we're not just going to learn about it, we're going to get you the cheat codes to absolutely smash any question they throw at you.
Okay, let's dive right in. Here it is, the final boss. This is exactly the kind of question that can make or break your paper. Now, I know it looks a bit scary, but trust me, by the end of this, you'll have all the tools you need to beat it and just grab those 3 marks. Easy. So to take down this boss, first we need to figure out its weak points. And that means we need to get a really solid grip on what an embedded system actually is. Let's decode this thing. Okay, this is the core definition. You've got to lock this in. Just think of it as a computer with a serious one-track mind. It's built for one specific job, and it's always hidden away inside a bigger machine. And here's a mind-blowing fact for you. Something like 98% of all computer processors made today are for these systems, not for PCs or phones. You know, one of the first, and honestly, one of the coolest examples ever was the Apollo guidance computer. I mean, come on, it was a computer embedded inside the lunar module with one epic job: get astronauts to the moon. No TikTok, no messaging, just pure dedicated focus. Now that's a specialist. All right, pop quiz for you. Imagine a little computer trapped inside a toaster. Its only purpose in life is to make sure your bagel is perfect, not burned. What is it? You got it, right? It's an embedded system. See? It's a computer with one job inside a bigger machine. You're already getting this. Okay, so we know what they are. Now let's just take a look at how incredibly common these little invisible brains are. I think you're going to be surprised where they're hiding. Seriously, look around. From the watch on your wrist to the washing machine, the traffic lights you see on the way to school, even the super complex systems inside an airplane, embedded systems are the hidden intelligence that makes pretty much everything in our modern world tick. They are literally everywhere. We can basically sort them into 3 big groups. First, you've got your portable stuff, things you carry around, like a digital watch. Then there's the stationary equipment that doesn't move, like a traffic light or a coffee machine. And then you have the really complex heavy hitters. We're talking about the brains inside a hybrid car or a massive MRI scanner. Okay, quick memory check. From what we just talked about, can you name one portable example and one complex one? For portable, maybe you said a digital watch or an MP3 player? Perfect. And for complex, a hybrid vehicle or avionics? Yep, you nailed it. Well done. All right, now we're getting to the really good stuff. These are the key properties. Think of them as an embedded system's superpowers. And for you, they're the secret cheat codes for your exam. If you can remember these 3, you can pretty much answer any question they throw at you. Superpower number 1, dedicated functionality. This means it's designed for one specific task. That's it. The computer in your microwave, it heats food. The one in your watch, it tells time. It's a total specialist, not a jack of all trades like your phone, which tries to do a million things at once. Superpower number 2, they run on things called microcontrollers. Now, just think of a microcontroller as a whole computer, CPU, memory, the whole shebang, all shrunk down onto a single tiny chip. This makes them way, way cheaper and more reliable than trying to stuff a whole desktop PC into your washing machine. And finally, superpower number 3, they are built tough. They're designed to use very little power, fit into teeny tiny spaces, and be incredibly rugged. They have to handle all the heats and vibrations from being inside a car engine or a spinning washing machine, places that would completely destroy your phone in about 5 seconds. Okay, you've got the knowledge, you have the cheat codes, it is time. Let's go back and face that final boss and use what we've just learned to build that perfect 3-mark answer. So, here it is again, the follow me system in a car. Let's apply our 3 superpowers and break down exactly why this is a textbook example of an embedded system. And here is how you do it. For your first mark, you hit them with its dedicated function. It controls the car's speed and distance. That's its one job. For mark number 2, you point out that it's part of a larger machine. It is literally embedded inside the car. And for that 3rd and final mark, you explain that it has to be optimized and rugged to survive the tough environment of a moving car. All the shaking, the heat, the cold. 3 points, 3 marks, boom, job done. Right, you've seen how easy it is when you know the formula. Now, it's your turn. Let's just do one more quick rep to make sure this is all locked in your brain for good. So here's a similar kind of challenge. Think about the controller inside a washing machine.
Why is an embedded system the perfect choice for this job? See if you can pick out two of those superpowers we just talked about. I'll give you a second to think. Okay, did you get them? Here are two perfect answers. First up, low cost. Companies make millions of washing machines, so that little computer inside needs to be super, super cheap, not like an expensive desktop PC. And second, it has to be rugged and reliable. I mean, a washing machine shakes, it gets hot, it deals with water. It needs a controller that can take a beating for years and years, unlike a fragile laptop.
And there you have it. You've cracked a code. The secret is, once you know what you're looking for, you suddenly start seeing these invisible brains absolutely everywhere. In your TV, your microwave, your parents' car. So, my final question to you is, what embedded system are you going to spot next?